Thank you. I'm Ben. I've always wanted to be one of those people on stage talking about inspirational subjects and teaching important lessons. However, I only have 5 minutes, so I'm just going to talk about dev containers instead. So they've been around for a little while. I actually started using them myself as part of the Cloud Adoption Framework development, where they were called the Rover, the CAF Rover, which really kind of stuck with me because I loved that idea of the Mars rovers and these things having things in common, where they're both built to be portable and completely self-contained, but also have all the tools and dependencies built right into them. So you don't need anything else. They can be completely self-sustainable no matter where they are. And they allow you to get down to the business of doing development work faster and more consistently. And that's what we as developers want, right? Like to get down into the code and do what you do best, and do it on whatever device you have in front of you at the time, and whenever inspiration happens to hit you. You just open a project, start coding, and just be a developer. There's no mess around with needing local admin rights or installing software and setting it all up. It's all, you build it in as code and off you go. There's actually a bunch of companies starting to make use of these, this mechanic to really great effect. The biggest one that I've actually been using myself is GitHub code spaces. And it was a really easy migration path between like the old, just using in VS Code and writing my dev container definitions myself. And I just put the code into GitHub, hit code space, and it said, oh, you've got a dev container already. Cool, I'll do all that stuff for you. Made it much easier. It has, has the IDE built into the browser if you want, or you use your own IDE on your machine. But it also has like really cool features like port forwarding and browser preview. So all those things you'd usually do on your machine, you can just do up in a container on GitHub's or infrastructure. It even does really cool stuff like Kubernetes and Docker, so you can run an entire Kubernetes cluster in that little container if you've given it enough resources. And this is now how GitHub does all of its internal development. All of their staff use code spaces themselves to do all of their development. Another one that's done really great stuff in the open source space is called Gitpod. They allow for cloud hosting or self-hosting, so you can choose where to put it. It allows for multiple different Git providers, so you can use Bitbucket, you can use GitHub, you can use GitLab, however you want it. And they've put in a whole bunch of really great open source automation to help you with that. An honorable mention on this is a operating system project called Nixos, which while it isn't necessarily containers, it allows you to do that it follows the same idea of having those good controlled boundaries around your workloads and allowing you to do stuff in a repeatable manner via code. And make sure it's consistent all the way through. You can also do it on your own computer yourself, like I said previously. And what this gives you is a really good, clean dev environment to start off with. You're not pulling along baggage from other projects and that weird hackathon you did the other month that you had to install one thing for. It's all self-contained. It doesn't impact anything else you're doing. You always have the right packages and dependencies because they're all defined in code. So you can standardize everything and make sure that follows you between your devices or even between your team members. So onboarding a new team member doesn't have to sit them in front of a wiki page and scare them to death by telling them to install about 1,000 things. And if people have opinions about what the dev environment should look like, easy. Do a pull request, everyone can vote on it and make it, and you kind of democratize your dev environment inside your team. And probably the best part is your code in dev can be taken from dev all the way through to production because it's the same container. If there's no more, it works on my machine because, well, yeah, the machine you're working on is now a container that can be thrown into production and work. I use it almost exclusive now. I'm going to be using it this month for Advent of Code, so I have a daily Python dev container ready to go, and I can even pull out my iPad on my machine. And at the end of the day, I get to just be a dev, and I don't have to worry about being package manager. So thank you very much.
Okay, so I'm Paul Costello, and I just thought I'd write a couple of things about what people talk to me about and ask me about is how do I get to be a cloud engineer? So I'll just quickly go through what myself and some of the people I work with go through with working in the cloud. So what should your experience be? Well, if you've come from a development background or a system admin background with Linux or Unix or any of the X's, or an infrastructure architect and you're tired of waiting for machines to arrive from overseas that take 6 months, then that's probably a great background to start with. What should you do? Well, the main thing that cloud gives you is the ability to, excuse me, the ability to experiment. The beauty of the cloud is that you can spin up a whole rack or data center full of gear and then take it down again. Trying to do that in physical reality is a lot harder and a lot more purchase orders. So studying and experimenting and understanding the way different functions work within the different clouds, whether they be AWS, GCP, or Azure. What should your attitude be? Well, it's pretty much a can-do. Because you are doing something in a virtual space, which we're all sort of used to now, you can do things that you've probably never been able to do before, like stand up a whole heap of equipment or a whole new database technique that you've never used before and see how it goes without actually going and getting permission to stand up an experimental environment that takes lots of approval and many hours. You can basically go and spin something up, see if it works, and if it doesn't, that's okay, and if it does, then it gives you a new path to go forward with your organisation. Do you need certifications? Yes and no. It certainly helps. I know some companies, some employers will not look at cloud engineers under a certain level, above associate. So for AWS and for Azure, probably similar. Certifications don't necessarily mean that you are capable of being a great cloud engineer, but what they do is they give employers and others a baseline of where you're at. So it gives others an idea of, right, well, they know how to do this and this, but I want them to do X. So that means that they've got somewhere to start. Do you need to promote yourself? Well, yes. It helps, and it helps get your name out. It's not selling yourself as such, but it's certainly getting your name out that you know what you're doing as far as cloud's concerned, or you know what you're doing with Kubernetes, or you know what you're doing with S3, with any of the things that cloud can provide. So, yeah, just go out, become part of the community, give talks and experiment. Do I need to specialize? Yes, and it will help. Cloud products and features are changing all the time. AWS has just got reInvent. They're introducing new services, everything like that. So yeah, if you don't specialize, you won't be able to keep up. That'll be the hard bit. How do I do all this? Well, if you make time, create your drive, and certainly find a passion of what you can do. That's probably the most important thing. If you've done all these things, an employer will probably seek you out on LinkedIn or any of the other socials. So in summary, build on your strengths, keep learning, share what you do, and be kind to others. Thank you.
Hi everyone, I'm Alice, Security Training Manager at a little Aussie tech company called Atlassian. The user is not the weakest link, you are. I know this is a bit forward of me because we don't really know each other that well, but bear with me as we do get to know each other a little bit better. We are all good humans. We're also fallible though. Humans are end users, but humans are also designers, builders and developers, aka you. Given the audience here today, I wanted to share a quote from Shri, our Chief Technology Officer, that I think Eric already shared. As it was very clearly stated in a town hall a couple of years ago and still rings true today, security and reliability at Atlassian are greater than features. So when you're grooming the backlog, or more likely wrangling the backlog at Atlassian, teams prioritise security and reliability before features. P.S. if this sounds kind of what you're about, guess what, we're hiring, so come find Luke, John and I for a chat. In my relatively short time in the security industry, I've seen security teams play a lot of whack-a-mole. It's like fighting spot fires. Constantly fighting fires is exhausting. Having the same findings on security reports each year is really a sad state of affairs too. I've looked into the tired eyes of the engineering teams. I've heard the exhaustion in the incident responders' voices as they're coordinating the mitigation efforts. There will never be enough people, processes or technologies to keep up with the threats and the risky behaviours of our well-intended but fallible humans. But what I'm thinking is less whack-a-mole and more strategic efforts that treat the highest risk first and focus on controls that are most effective. We can save on some of this burnout. One way to understand and treat your risks is via threat modelling. I love that one. Threat models help us to determine the risk of your applications by inspecting the effectiveness of your security controls. Two of the most valuable attributes of a threat model are being able to clearly document the threats and being able to then drive valuable change. Threat modelling could be a lightweight risk assessment. You might use a checklist to look for weak design elements, or you could rate the criticality of your system related to the operations of your business, categorise the sensitivity of the data that you're using, or poke components for common vulnerabilities from the OWASP top 10. Or it could be a bit more of an extended version, which is a workshop where you could spitball what could go wrong, what juicy data the application is handling, processing, storing, parsing. There might be a bit of design sparring too. Microsoft has its widely used Stride threat modelling framework, or you could ask Christian in the audience here today about his HCLMTM on GitHub, which really aims to provide a DevOps first approach for documenting a system threat model. The outcome of a threat model is a living document that can be updated over the application lifetime. So when you're looking to address those findings that you found during your threat modelling, because you've done it, you really want to consider, I really like you to consider the hierarchy of controls and always aim for elimination. This might not look familiar to you, this hierarchy of controls, but it's foundational in the health and safety risk management, which is where I've come from and is very transferable to security. So you're probably wondering why I'm dressed in my corporate high-vis. Just can't get the safety out of that girl into security. But I wanted to demonstrate the least effective control, which is PPE. While it's great that I might wear my high-vis jacket so I'm more easily spotted on the side of the freeway while I'm working and inspecting some sort of pit, I'd much prefer a barrier between me and the traffic, freeway traffic that's going 100 k's an hour and with Perth drivers. Admin controls are a low level of effectiveness as well and really relies on culture. So unless you've got a good culture, you're going to struggle with this one. Culture is what happens when nobody is watching. So you can provide training and communicate about new procedures and policies, but what happens when the security team isn't watching? Will a developer still hard code the API keys and credentials? Here we go. Okay, now we're coming up to the middle range, middle tier, engineering. This is like permanently fixing a safety barrier between me and that freeway traffic. But what would be even better would be to eliminate it. Let's close the freeway altogether so there are no cars coming past at 100 k's an hour. An engineering control would be, for a cybersecurity context, is an engineer configuring firewall rules that allows packets or data to pass into a network or to be dropped and blocked at the wall. It might also be hot fixes, detection rule tuning. The thing that we have to be careful though about engineering controls is it's a human doing the engineering. Humans who create these controls are not infallible, but layering these controls can be really effective. So think about peer review, static and dynamic analysis, scanning for those API keys that might have been hard-coded. These can really support the human-engineered controls. Substitution to reduce security risk could be upgrading your operating system or switching to the latest or golden Docker image. Substitute a custom-built or unsupported authentication solution and policies with an offering maybe from your platform security team that's supported, if you're lucky enough to have one of those. And elimination. So in safety terms, this is like actually bending down and picking up those trip hazards from the walkway so nobody else trips over, including yourself. You could eliminate risk by putting some extra effort into removing tech debt before you go live with your change. You could remove libraries that are known to be vulnerable and or unsupported components. Now, I'm not pretending this is easy. The most effective things you can do are usually the hardest, but again, the goal should always be to eliminate, especially if their application is handling sensitive or critical data. Last week, I overheard a great conversation. I'm going to embellish a little bit like my shoes, but it went something like this. We just dig stuff up out of the ground, put it on a truck, and then put it on a train, and then put it on a ship. Cybersecurity isn't something we need to worry about. Other person from security. But I heard the use of these remotely operated autonomous trucks is ever increasing. Isn't there a threat of remote trucks being taken for a joyride by a bunch of hackers on a slow day who like Grand Theft Auto? How much does it cost to replace a big jump truck if it was remotely driven off the side of an edge of a mine pit? Thinking like that they could maybe jump gaps like Mario? This is the kind of creativity that you can bring to threat modelling, so no scenario is off limits. So just to reiterate on the weakest link statement I made at the beginning, you as developers and engineers are one of the strongest defences against threats to confidentiality, integrity and availability. Threat modelling is one practice you could build into your processes armed with your new knowledge about the hierarchy of controls. Thank you.
Hi, I'm Lloyd. This is why you should care about networking. So why do I need to learn it? It helps to speak a common language with the networking teams and other teams that you interact with. Understanding the key limitations of your environment and when you develop and then you push it out to the network, why there might be differences, and gathering the information to debug and explain the situation to other teams. And then you can monitor the key metrics you need to pay attention to. And then, the networking's changing. So we've got IPv6 adoption. We've got DNS over HTTPS. There's network error logging. We've got CPS and cores. Chrome is removing the user agent string, which is used to identify what browser people are using. So this might break some websites coming up. And then certificates are now shorter in lifespan. So this means that when you log in and you see that lock icon, it's 1 year max that you might need to rotate that. And then it's HTTPS first on most browsers now, so it's expecting to secure the traffic by default. The security is tied to networking, so CPS and cores, and they've got NACLs and security groups. And if you're going to focus on security, you should understand the networking in greater detail. So network error logs are a new feature that I discovered, which allows you to log back to a server what networking issues your users encountering, like the certificate or DNS resolution issues. And then, IPv6 is an old technology, but we've run out of address spaces, so you can see the rise of IPv6 in places like AWS, and I think there were some new announcements on that one. So there's actually 7 layers, but I've excluded them for the sake of simplicity. You only really need to care about these as sort of a developer to start with. So HTTP, FTP, DNS, all of that, SMTP and DHCP. This is how it's resolving where to go. And then you've got your session. So you've got your encryption, that's how the certificate's being used. And you've got your transport, so TCP, UDP, you should try and understand. And your networking, so you've got IPv4, and then IPv6 is the new address space where we're, And then, can I use my networking algorithms in my day-to-day? I did come across this one. So you can use exponential backoff with relatives. I'm not sure if that's suitable, but
you could say they don't turn off on time, you could back off to say, oh, we'll catch up in 2 weeks, and then 4 and 8, and so on and so forth. You're not saying no, you're just saying give it a bit of time. You can use a bit of jitter to randomize the result and delay, so they might not realize that you're doubling the time you catch up from them. Use this at your own peril. Please don't blame me if they don't talk to you again. And then caching is another one that you should understand. So your DNS cache can take up to 24 hours. This has caught out quite a few people, including myself. So then telling people that there might be a 24 outage for prod is a really bad conversation to have. So understanding how you shift that over without an outage is really important. Content caching, so what part of your sites can be cached, how long it can be cached for, how long you allow users to be logged in terms of the session. Do you need to limit it so malicious actors have limited time to act with stolen credentials, and how are you going to force a refresh? Networking topics. So yeah, if you're starting off this journey, so learn about the protocols, learn about HTTP, HTTPS, TCP, IP, and then you might dive into TLS, REST, and then IPv6, and then you might start off with caching policies and tools, so content delivery network, your caching tools, DNS cache, your CSP, cause, network error logging, and certificates. And then you might dive into a tool like Wireshark if you want to understand it in depth, or you might start learning these tools like Telnet, curl, traceset, NSLookup. Cool. That's it. Thanks.